All right, friends, it's your boy, Mr. Shagney, coming at you with Lesson 12 homework. Today in class, we talked about constructing the coordinate plane, looking at the numbers you count by or the scale that's used when drawing the coordinate plane. So the first problem reminds us of this. It says, draw and label an appropriate pair of axes and plot the points. And so from class, right, so we're going to draw, this is my y-axis, and this is my x-axis. And so I'm gonna now look at these points over here. I have, it looks like fifths, right? And so from class we did the fractional part where we had the fractions and they were fours. To me, I'm gonna count by fifths on this. I'm gonna count, each tick mark is gonna be a fifth. So this would be 2 fifths, 3 fifths, 4 fifths, 1 whole, and then 1 1/5, and then same thing over here, negative 1/5, negative 2 fifths, same thing here, negative 1/5, negative 2 fifths. And so I'm going to plot 1/5, 4 fifths, so 1/5, and then 1, 2, 3, 4, that should be 4 fifths. So 1/5, 4 fifths is going to be about there. Negative 3 fifths, so 1, 2, 3, and up 2 fifths. So about right there. Then I have negative 1 1/5, so I need to extend this line a little bit. That's 4 fifths, 5 fifths, 1 1/5. So that's negative 1 1/5. So that's 1, 2, 3, 4, 5, and that's 6 fifths or negative 1 1/5. And then negative 4 fifths would be down for 1, 2, 3, 4, about right there. And I'll put those lines in. And then 1/5, and then negative 3 fifths, so 1/5, and then down 3, 1, 2, 3, about right there. So the whole point of this is that draw and label an appropriate pair of axes. So I need to see x, I need to see y, I need to see the scale that you're using. What are you counting by? If you can't fit all the numbers in, it's perfectly okay to do this, because it shows me that you understand that we're counting by our scale used as fifths, because that's going to allow us to include every point in our data set. The next one, Clara was asked to plot these points: negative 50, 0, 150, 100, 200, negative 100, 350, 50, negative 250, 0. What interval, what could she count by on the number line? Could she use for each axis? Clara. And so for this problem, explain your reasoning. So I see that 50 goes into each one of these numbers. So to me, I would think that she could count by 50. Clara could count by 50 because each ordered pair are multiples of 50. Right? So Clara could count by 50 because each ordered pair are multiples of 50. 0, 0 is easy to count by because if each other number you can count by 50, but 0, you go from 0 to 50, that's perfectly fine. The next question, the next two questions kind of go together, so we want to kind of take this slow. It says, name 4 points that would form a square with the origin at its center. Remember that the origin is where the x and the y intersect. Right? So this is my x, this is my y, and this is the origin. Now, it's saying name 4 points that would form a square with this point as the center of the square, right? So we want to label 4 points that would allow it to be that at the center from each side. So we want to think about it that way. So if I'm thinking about a square, right, I know that a square is equal distance. So if I went out 3 that way, and then I'm going to go out 3 this way, 3 this way, and 3 that way, right? I'm just going to do that. So remember, a square, if I were to think about it this way, if I were to plot. I need to have it 3 distance. I need to have this dot be the center of that circle, of that square, right? So I'm having a brain fart. So I want to think about ordered pairs, and I want to think about what makes a square a square. Well, a square has equal sides, so each side has to be the same. So if I were to plot one here, and here, and here, and here, that'd be 1, right? But would it be the same distance from each side? Yeah, it's a possibility. So what I want to try is I'm going to go over 3, and I'm going to go down 3. So if I did that, I'm going to go over 3, and then I'm going to go up 3. I'm going to try that. I'm going to go over 3, up 3 here, and then over 3, down 3 here. Well, if I connect these, the origin, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. It's the equal distance from this point. So if this is negative 3, 3, and this is 3, 3, right? What they have in common is their y-coordinate is the same. So it's the change of the x. So x is going 6 units. So we know that this is 6. So to make a square perfect, right, we need to make sure that it's going to work out. This is from here, this is 3, negative 3, and that's the same, right? And that's also a distance of 6. So, and then this one would be negative 3, negative 3, and that would also give me 6. So this is a possibility here. We have negative 3, 3, 3, 3, 3, negative 3, and negative 3, 3. Right? Those have the origin at the center. So that's something that needs to work out. And then, of course, this is to 4. Number 4 is shown right there. This is the 4 points for number 3. So I really want you to think, if this is supposedly at the center, right, then we know that it has to be the same distance from each side, and it is 3 units from each side. I am wondering if we did, 2, and then 2, like if we did something like that, if that would also work, or if we did 1, and then 1, if that would also work, right? I'm wondering if that would also be a possibility. So that's something to think about. It's a great question. It's something to keep in mind because it's really thinking about your understanding of, a square, origin, and then plotting points and the distance between 2 points. Remember that in class we talked about if you're looking at those 2 points, they're sharing the same y-coordinate because this is a horizontal line, and that indicates that the y-coordinate stays the same, but you have a difference, right, between these 2 numbers, which is 6 units apart. They're 6 units away from each other, which is how we are able to define, or how we're able to assign numbers to geometric shapes in the coordinate plane. All right, so that's that part. And then on the back, number 5 says, which of the following changes would you represent with a negative number? Explain what a positive number would represent in that situation. So in this one, right, so a loss of 4 points, that's a possibility with a negative, and then a loss of $10. And so that's the first part. It says identify which of the following would you represent with a negative number. I represent both of those. And then explain what a positive number is. So this would mean a gain of 4 points. So that's the opposite of that. A gain of 4 points. Explain what a positive number would represent in that situation. And this would be a gain of $10. Right? So it's kind of connecting back to what we did a while back. This last question, I forgot to put the part of the question down, but this is a pretty cool thing to look at. So it says, to get from the point 2, 1 to negative 4, 3, you can go 2 units up and 6 units to the left for a total distance of 8 units. This is called the taxi cab distance because the taxi driver would have to drive 8 blocks to get in between these 2 points on a map. And so it's asking you, what are all the possible ways that you could look at this problem? So you want to be able to go 2 units up and 6 units to the left. And so we're trying to look at all the possible ways that one, so the other question for this is, it wants to say, find as many points as you can that have a taxi cab distance of 8 units away from this. So this is 8 units, right? That's one way to represent that. We're trying to look for as many different points that make 8 units away from this point. So I'm going to start here, and I'm going to go 8 units. 1, 2, 3, 4, 5, 6, 7, 8. That's one possibility. That is, if I were to add 8 to 2, that would make 10, right? Comma 1, because I added 8 units just that direction. Another direction is I could go down 1, right? And I could go 1, 2, 3, 4, 5, 6, 7. That would also be 8 units away because I did 1 there and then 7 there. And that distance would be, right, 9, 0. And so I'm looking at that, right, thinking, okay, then I can go down to 1, 2, 3, 4, 5, 6, 7, 8, right? And so you can kind of see there's a sort of a form of pattern there, right? So you can kind of see that maybe the next one would be there, right? So it kind of continues that trend. So I'm going to check these points. 1, 2, 3, 4, 5, 6, 7, 8. So that seems to be the trend, right? That these are 8 units away. So 1, 2, 3, 4, 5, 6, 7, 8. So you can kind of see something happening here. So if I go 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8. So if I were to connect, right, if I were to think about this, I'm pretty sure once it hits here, right, so then I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, right, and kind of fill in those gaps between these 2 points because those should make it up. And then 8, so that would be 8. It's kind of like this, right? It kind of helps me visualize it. And then if this is 8, then it's going to be like a corner there. And hopefully I'm following the pattern. So once you have found all ways that are 8 units away from this, you'll notice that it forms a shape, and that shape is a square, right? So these points form a square. And so that's the cool thing about taxi cab distance is even though they're 8 units away from this location, they're going to form the square. And so I'm signing out with this homework assignment saying the cool thing about this is that, you know, we're really focusing on plotting the point and understanding the location of the point, and then what happens when you have 8 units from the center, right? So this kind of connects with, this question kind of connects to what we did previously on the first page, because all these points, if this is the center, right, all those are 8 units away from that, and it makes a square, right? So if the origin is the center, then it, again, is a square, as long as they're equal distance away. So this is Mr. Shaggy signing out. If you like this video, you can hit a quick subscribe, and I'll be back at you tomorrow.